We're looking for the last 3 digits of the floor of this giant quotient. Now, y'all, the floor returns an integer, and so that's one of the reasons we're actually it's even important because you don't have to worry about any digits after the decimal point. Now, just an idea of how the approach we're going to adopt right here. Notice, let me just make up something here. What if we had the, let's do 8,612. Okay, now notice that this is congruent to its last 3 digits for the appropriate choice of modulus. Okay, moduli, I guess, plural. That would be mod 1000. Okay, so that's in modular arithmetic, mod 1000 is always going to reduce to the last 3 digits of the number. Okay. So keep that in mind as we continue. Here's the definition of the ceiling, or the floor function. I'm going to trust you know how to use it just to save some time. Now, the key idea here actually is to rewrite this. Okay, and this is in an equivalent form that was obtained by dividing through by 999 raised to the 13th power. Now, why this is important, and I'll write it out to the side, I suppose. This actually is in the form of an infinite geometric series sum, which is not that obvious just in this context, but we'll let f be the first term of our infinite geometric sum, and it's very well known that this is the formula for an infinite geometric series with a common ratio r. Now, again, I'm just using different letters. F stands for first. Sometimes they use little a here, I guess, or something, I'm not sure. But the first term, and then plus the first term times the common ratio. And then you're going to square the common ratio. And we are assuming for this thing to converge that the common ratio is a number between -1 and 1. Some people might say the absolute value of r is less than 1. And I'll put the customary ellipse here to indicate this goes on and on and on like this. Okay. Now, so what we have is an expression that we're trying to find the last 3 digits of. And we want to use this approach, and you'll see why it's a good idea if you don't already. Notice that the first term is would just be 999 raised to the 53rd power, okay? And then the common ratio, it's easy to identify right here. Three over 999 raised to the 13th power. Okay, that's supposed to be a 3, ladies and gentlemen. Okay, and y'all, that's what I've done right here. Literally, here's the green, and this is, I had to go this small just to keep it all on one line. But notice here's your first term. This would be like your, let me just write down, for example, this would be the f r squared term right here. Okay, that would be the f r squared term from our result up here. We took the common ratio and squared it. If you square this guy right here, you would get 999 raised to the 26, which is, hopefully you can see that right there. Okay. Now notice we'll reach a point where all of these terms are less than 0. Let me just circle that, or less than 1, excuse me. This circled object right here, along with a bunch of terms that I can't write down, is less than 1, right? Okay, so let's keep moving. The rest of this is fairly, let's see what we do right here, 999 cubed. Just the simplifying stuff here, 53 minus 13 is the 40 you see here. So we're just simplifying algebraically here. Now, something that's quite important here, as far as the modular arithmetic piece, observe that 999 is congruent to -1 in our modular arithmetic form, okay? And again, I'll just go ahead and write it in right here, mod 1000. Okay, and also, I'm running, I guess I can do it right up here, or I want to keep it on the screen here so everybody can see it. 999 squared is, 999 squared is congruent to 1 also. Now that's very, very easy. Just think of 1000 minus 1 quantity squared. Well, remember 1000 is 0 mod 1000, right? So that means that 999 squared is congruent to 1, and this is mod 1000. Y'all, apologies. This marker's on the fritz for some reason. I don't know what's wrong with it. But maybe the operator's on the fritz. But notice we have these two important results. 999 squared is congruent to 1, and 999 is congruent to -1, all mod 1000. Okay, now what does that do for us? Well, it does a hell of a lot. Notice right here, the 999 squared just becomes 1. You see, folks, 999 squared is 1 modulo 1000. And it's real easy to see is the difference of two squares. You will get 999 plus 1, which gives you the 1000 right there, okay? So this piece right here gives us just -1, okay? This piece right here just gives us 3. And y'all, I'm reducing modular here. Right there. Y'all, that's a 3 there despite my, okay. And then right here, what do we have? 9 times we have minus -9, or just -9. Okay, and then right here, plus 27. See, y'all, just all this massive number is getting reduced down to a very small, manageable number. And then right here, finally, we have minus 81. Okay. Pretty amazing, isn't it, folks? Just super large numbers are getting just reduced to remainders, basically, modulo 1000. Now, what do we have here, folks? I'm getting that this is equal to -91 for the minus guys, and then plus 30. Equals to minus 61. Now, y'all, let's keep our eye on the prize. What are we looking for? We're looking for the remainder of this thing. And this is not going to be a remainder, mod 1000. A remainder would be a number between 0 and 999, right? So notice that this is congruent to 939. friends. And so let's come back up here, and I'll just write it up here so you'll have a better, the last 3 digits would be 939. Let me get that circled. And it's really quite fascinating, folks. Now I may have glossed over just a little bit too much right down here. Notice how I kept this piece out here that was always less than 0 or less than 1, right? And and then though I got rid of it when I took the floor. You see I did want to point that out. This piece right here is definitely a number between 0 and 1, a very small number between 0 and 1, right? I didn't have it written as the floor, but now we can write the floor by just omitting all of those trailing negligible terms. And you can see where right here, just we came to here, we just got rid of this circled piece right here in the process of taking the floor. Okay? So anyway, that does it, folks. 939. Plug it into your favorite piece of technology to verify that the floor of this giant number has a last three digits of 939.